Okay, in this video, hopefully we're going to wrap up the rest of the homework problems. In 23 and 24, we're given a line and we're given a point. We need to do two things. One is we want an equation of a line that is parallel to the original line and passes through that point. Second, we want an equation of a line that is perpendicular to the original line and also passes through a given point. So the first thing we can do then is to find the slopes of these lines. So the first line goes down 1, 2, 3, 4, and right 1. So the old slope is -4/1, which is -4. So when I want to be parallel to that line, I have to have the same slope. When I want to be perpendicular to that line, I want to have a slope that is opposite and reciprocal. So why don't I just say it this way? Parallel slope will be -4. Perpendicular slope will be 1/4. Right? So in each case, I'm going to have the point 4, 3. So what I do here then is I'm going to set up two different point slope forms. Y minus y1 equals m times x minus x1. So we'll call this one the parallel line. Alright, so if I'm parallel, I want to have the same slope. In either case, I'm going to pass through y equals 3. For parallel slope, I have -4x minus 4. Y minus 3 is equal to -4x. -4 times -4 is +16. Add 3, and I get y is equal to -4x plus 19. So that is my parallel line. Next, my perpendicular line, y minus y1 is equal to m times x minus x1, and this time my perpendicular slope, notice the point that I'm using is the same in each case. Perpendicular slope will be +1/4 x minus 4. I get y minus 3 is equal to 1/4 x minus 1 plus 3 plus 3, and I have y is equal to 1/4 x plus 2, and this is my perpendicular here. Alright, so that's for A. For B, also, this time we are not given any points on there, so we have to find our own points. That looks like a good point there. That looks like a good point there. And so we're going to go up 3, right 1. So we'll say that our old slope is 3. Then our parallel slope will be 3, and our perpendicular slope will be -1/3. So we're going to again set up two different equations. Y minus y1 equals m times x minus x1. In this case, we want to pass through the point 3, -2 each time. So y minus -2 is y plus 2 is equal to, this will be my parallel line. So I want my parallel slope to be 3. X minus 3. Y plus 2 is equal to 3x minus 9. Subtracting 2 on both sides. Y is equal to 3x minus 11. Careful there. And this is my parallel right? In the second one, y minus y1 is equal to m times x minus x1, and y plus 2 is equal to negative 1/3 x minus 3, y plus 2 is equal to negative 1/3 x plus 1. Subtract 2 on both sides, and I get y is equal to negative 1/3 x minus 1. And that is my perpendicular line. Alright, so A is the first two, where 23 is over here on the left, 24 is up here on the right. Alright, well, let's go on to the next problem. In the next problem, we have a Parks and Recreation Department is constructing a new bike path. The path will be parallel to the railroad tracks shown and will pass through the parking lot at the point 4, 5. Write an equation for this line. So we know, first of all, that we have this point 11, 4. We need to know what the slope of that railroad track is. The slope of the railroad track, we have one good point so far, but we need another good point. And I am going to assume that this point way up here is another good point. Let's see what that gives us for a slope. Up 1, 2, 3, 4. Up 4 over 3. So the slope of the railroad track would be 4/3. So let's go backwards and see if we get the same thing. We go back 1, 2, 3, down 1, 2, 3, 4, and that brings us to what looks like the 8, 0. Actually, I didn't see that. There is another point clearly there, 8, 0. So we can either find the slope using the method that I just used, or I can use y2 minus y1 over x2 minus x1, which would give me a slope of 4 minus 0 over 11 minus 8, which would be 4/3. So either way is good. Now we want to be parallel to that line. So old slope is 4/3, and parallel slope would also be 4/3. And we want to pass through the point 4, 5. So all we need here is y minus y1 is equal to m times x minus x1. Y minus 5, that's our y coordinate, is equal to the slope, which is 4/3 x minus 4. And we get y minus 5 is equal to 4/3 x minus 16 over 3. And they want to give us a hard time here, so we'll have to deal with fractions and whole numbers. Y minus 5 is equal to 4/3 x minus 16/3. And we're going to add 5. Well, hopefully you know that 5 is the same as 15/3. So when we add that, we get y is equal to 4/3 x. Sorry, I forgot my x there. Y is equal to 4/3 x minus 1/3. Okay, and so y equals 4/3 x minus 1/3, and that is the equation of the bike route. Right, so because it's 1/3, it would end up somewhere down here, and you can see that if we were to draw a line sort of like that, then that makes sense that those lines would be parallel there. Alright, we come down to the last problem. And that last problem, oh,